Dear all, in this session we will discuss about different aspects of transformers and pipelines in deep learning. In generative AI also, the transformers and pipelines are widely used for content creation, content summarization, for different types of implementations. So we will see by which way we can associate this particular paradigm, transformers, pipelines, and by which way it is working and how it is associated with generative AI. Nowadays, we are in the timeline of generative AI, large language models, retrieval augmented generation, RAG, MCP, context, model context protocol for content creation, training our own models. We will see different implementations. You might have seen in classical search engines also, in when we search on Google, when we give some particular prompt, when we give some specific keyword, then we are given some suggestions, upcoming words. So that is also implemented using transformers and pipelines. First of all, we will see what is the main work or by which way transformers work at the back end, or key ideas behind implementations of transformers in machine learning and deep learning. So a type of machine learning or AI based model that is able to analyze the sequence of data at once, to evaluate the entire data and to find out relationships between different combinations. For example, we have some particular statement, some specific audio, and from that specific audio or statement, we want to identify certain patterns. We have a sequence in a specific sentence. What is basically a sentence? That is a sequence of words, sequence of keywords, and we want to associate that particular sequence of words to specific nouns or specific relationships. For that, we use transformers. In classical implementations, in classical deep learning based models like RNN, LSTM, you might have seen that data is analyzed step by step, some specific memory locations, some specific memory blocks are used to store the data, to store temporary data, and after that, some predictions are done. Rather than using the paradigm in RNN or LSTM or GRU, transformers take the complete sequence at once, and with the implementation with a specific mechanism that is known as attention block, the associations are find out, associations are extracted. For example, we have written x knows b, x knows y, where, or x knows y, where that belongs to f. So we want to associate to which particular character, to which specific block that refers to, that it, or such type of keywords we want to associate to some specific block. In case of chat gpt, in case of bert, in gpt based implementations also, transformers are used. So key idea behind transformers are smart models to understand the relationships in data, okay, relationships of data and words, by which way words are associated in a specific sentence. And once these statements are identified, then we will be able to work with translation, summarization. We can go for some content extraction. You might have seen when we go for translation in one language to another language, then many points we have to consider. Rather than straight translation, we have to see relationships. So by which way it is done? For example, this one is the statement, this one is a sentence. Okay, cat sat on mat because it was tired. So what is, so to which particular block or to which specific keyword it is associated, whether it is associated with mat or cat or any other word. Okay, so with use of transformers and its integrated attention block, it will decide, or it will be referred to the appropriate keyword. However, other words are also available, so you can see that in this other words are also there, but it will identify, it will find out the matching, best matching. And by which way this particular best matching will be done? That particular best matching will be done depending upon the vectors, depending upon vector databases. Because at the back end of these transformers, at the back end of these type of implementations, we have to work on vector databases. Each and every word, each and every keyword is converted to numeric format. For example, we are giving this particular statement, so cat sat on mat. Each and every word will be converted to numeric value. Each and every numeric value will be evaluated with attention parameter, with attention block, and it will decide further at the time of translation, at the time of summarization or content generation. Even for example, we want to generate complete paragraph from this single sentence, so that particular paragraph generation or content prediction will be done by attention block. Okay, it makes use of certain vector calculations, vector measurements, and it will decide what is distance between certain words. Okay, it will find out how, what is the distance and what is the relationship between different keywords. Okay, so this one is the big picture in broader way by which way transformers work. So very first step in transformers, that is embedding, turn words into numbers. For example, this is the statement. Okay, cat sat on mat because it was tired. We want to expand it, we want to translate it, or we want to associate it with cat or mat or whatever it is. So first of all, embedding will be done. Turn vector words into numbers or vectors, that is known as embedding block. Very first step in transformers. Second is to figure out which words are important to each other. So this particular task is done by attention block, by attention mechanism, to find out the relationships. So it will decide whether this particular word is associated with this or any other. Okay, to find out best relationships. Generate an output, prediction, translation, summary, text generation. We want to expand something, we want to shorten something, each and everything. So three blocks are available, three blocks are used widely in transformer architecture. Encoder, read the input, like reading a sentence in English. For example, in chat GPT we are giving some input, so first of all it will be encoded. First of all, that is converted to vector, that is converted to numeric format. After that, attention mechanism, so it will find out what we want to ask, what is meaning of our sentence, or by which way it is related to the backend large language model, backend LLM that is trained. For example, complete database, complete data set of chat gpt, complete data set of Gemini or Copilot. So using attention mechanism, it will be decided to which block it will be associated, and decoder generate the output. in Hindi, English, or whatever it is. Okay, so depending upon our implementation scenario, that particular content is generated. So in this way, so if we discuss it with one example, with very simple example. Okay, first of all, we are discussing about the paradigm part, about implement, about step by step and conceptual part. After that, we will come to implementation. We will see how to implement transformers in Google Colab with Python. So, for example, this one. So, very first step, that is embeddings. This will be converted to numeric. Okay, each word converted to vector list of numbers, as just now we have seen in encoder block. Each and every word will be converted to number or vector. If we are developing an LLM similar to ChatGPT, RAG, then in vector databases we will store the complete data set. Attention mechanism. What attention will do? Attention will find out the relationship and highly or less relevant blocks. Okay, which particular words are strongly connected, which words are loosely connected, okay, less connected. And in third, self attention, feed forward. So these blocks are used. Okay, and finally decoder plus output. So output will be generated with in association of decoder, but in between decoding and input embeddings, attention mechanism will make use of self attention, be feed forward and stacking. Okay, how many layers are there, which how many weights are required, assignment of weights to each number, to each vector, and to check whether whatever output is getting generated, it is accurate or not. Okay, so broadly we have three: encoder, attention, and decoder. But as far as attention mechanism is concerned, it is associated with feed forward network similar to neural networks. Okay, at the back end, this particular strategy is used, in which different layers are used depending upon our input, how many tokens we are giving. So you might have seen in Chat GPT, in Gemini, Copilot, we use the term tokens. How many tokens we are using? So depending upon those tokens, it will be decided that how many layers are required. Okay, by which way weights to be modified. So self attention, within encoder decoder, each word compare itself with all other words. For example, this particular word, so this particular word, for example, cat word will be associated, it will be related to all other words. So what is the relationship of cat with other words? What is the relationship of sat with other words? What is the relationship of on with all other words? So in that case, a particular tabular data is analyzed. Depending upon that, weights are associated or important scores. Okay, scores are evaluated, and once this particular relationship data is generated, then we go for layer, deciding the layers. Okay, at the back end, this these things are analyzed. Okay, so, and as far as pipeline is concerned, okay, so what is transformer? Is a big architecture. It is a complete model. Along with that, to work with the transformers, what we need. If I want to take output, if we want to take some particular result from transformers, we need a particular pipeline. So pipelines are used to implement transformer for a specific implementation, for a specific task. So what I want to do, I want to do summarization for, so for that so that specific time pipeline I will use. Okay, what is transformer? Transformer is the architecture. Transformer is providing the complete model, complete architecture, in which attention is there, embeddings are there, encoding decoding layers are there. But how to use means pipeline. So you can imagine it with a car. For example, we have engine. Okay, car engine. But with only car engine we can't move, we can't travel. If we want to travel from x to y, from one place to another place, we need a complete car, we need a complete vehicle. So that vehicular interface will be provided by pipeline. Okay, what we want to do, that is done by pipeline. Backend architecture, that is a transformer. If I want to use for example a text summarization, I will use pipeline, but at the backend transformer will be used. Okay, so you can imagine or you can think transformer as an architecture, as a model that is having everything: data, embedding, attention, decision making, everything. But its use case, its implementation scenario, in programming languages you might have heard a particular term that is known as API. We use application programmers interface. Okay, API. So what API do? So with API we call a particular backend implementation, backend algorithm, or backend scenario. So in same way you can relate transformers and pipelines. So pipeline is the upper layer or top layer to use transformers. Okay, ready to use tool that wraps the transformer model for a specific task. If I want to go for example translation, I will use translation pipeline. If I want to use uh, summarization, I will use that particular pipeline. I want to go for prediction of next word or expansion of a paragraph, I will use pipeline. Okay, rather than taking entire transformer, its complete architecture, I will simply call pipeline and that particular function. That particular pipeline will make use of all steps at the back end: tokenization, model, okay, decoding, encoding, each and everything. So why at the time of working on a particular implementation, we make use of this particular scenario, pipeline. Okay, so pipeline is the upper layer or top layer to use our transformer. And these transformers and pipelines are available in different platforms. One of the very popular platform to work with transformers and pipeline is HuggingFace. Okay, so you can see that AI community building the future. So most of the corporate AI based models are available on HuggingFace. If I want to use a chat GPT model, I want to use a model that is by Meta, that is given by Google, each and everything is available. So you can see Google, Tencent, Baidu. I want to take a particular model by Meta, that is also available. So you can see Meta Llama. I want to work with Facebook model. Okay, Google. I want to use OpenAI. So you can see OpenAI GPT OS 20 billion parameters, 120 billion parameters. Okay, so which particular model we want to use? If I want to use this, so I will make use of its transformer. So this way, so you can see that if I want to use OpenAI model, chat GPT model, so in this way we write from transformers import pipeline, which model I want to use, which transformer I want to use. Okay, so that specific model ID we specify, and and in pipeline we give our input. What I want to do, text generation, I want to go for text translation, text transformation, text summarization. Okay, anything we want to generate, anything we want to present, that will be done with pipeline. Okay, but at the back end of pipeline, there are transformers. So you can see that this one, if I want to use it, so you can see this one use this model transformers. Google Colab, Kaggle, okay, transformers. So in 4 to 5 lines of code, we will be able to work. So text generation from transformers, import pipeline, and what I want to do. So some examples we will see related to this one. For example, one very simple example we want to discuss related to transformers and pipeline. So here also I have written transformer is engine of the car, and Pipeline is whole car with steering wheels by which way you can actually drive, by which way you can actually operate a transformer. Okay, because only this part is not required. We need a pipeline, we need input output devices, we need input output blocks. So those input output blocks, input output variables, or a complete pipeline, we can say, it will be implemented with this particular block. Okay, for example, we want to work with a particular pipeline for sentiment analysis. Okay, so we can do it from transformers import pipeline. What is the pipeline? Sentiment analysis. Which transformer model? Distilbert. Okay, any model you will be able to take. So you can see that in this code, I have not defined any model. I have not defined any transformer. Okay, you might be thinking, where is name of the transformer? Name of the if I do not specify the transformer, then Distilbert, it is by default. If I want to take GPT, GPT-5, GPT OSS, whatever it is, we will be able to take, we will be able to specify. Okay, so simply, so one more aspect you can see relation in one line. Transformer is the brain, okay, brain or model. Pipeline shortcut tools to use these. Okay, now I will execute it. For example, in Google Colab, if we want to execute this one, so I'm opening Google Colab, transformer pipeline. Thousands of transformers are available, and to use those transformers we can work with pipelines. So you can see that this one, so I have not defined any particular transformer here, so by default it will take Distilbert and run. If you want to go for text summarization, so two transformers, two pipelines we are using. One pipeline we are using for sentiment analysis, second pipeline we are using for text summarization. Okay, we want to check its sentiment score, whether it is positive or negative. For you might have seen in Amazon, in Flipkart, many times we have to evaluate a particular sentiment score, what people are discussing. For example, a particular paragraph, so from that paragraph we want to see whether it is positive or negative, so that we can do. Or we can go for text summarization. Okay, so this is complete text, and this complete text we want to summarize in few words, okay, or in few tokens. Actually, at the back end of GPT, at the back end of large language models, we use the term tokens. So, okay, how many tokens we want to use? So you can see that no model supplied, defaulted to Distilbert, base uncased. From HuggingFace, automatically it has taken HuggingFace transformer, and it will download these 10 tensors are down getting downloaded, and now you can see that it is positive. Okay, so this is positive. Whatever input we have given, what is input? I love learning about transformers, whether it is positive or negative. So this is positive. Okay, label is positive if you are working on sentiment data analysis. So one way to work on sentiment data analysis is that we will train our own data. We will train different data sets, whether these are positive or negative, and after that we will go for prediction. Otherwise, for quicker implementations, we can go for pipelines. We can directly call the transformer, relevant transformer. You can see that 1.2 GB. So these are corporate transformers, corporate level, industry level transformers, and you can see that we will be able to directly use it. So now we are summarizing it. So you can see summary text. So this is summary text. We are able to summarize. So whatever text, whatever paragraph we have given, for example, a long paragraph we have given, we want to translate, we want to summarize. If we want to translate it, so we will see that specific uh, pipeline which is required. Okay, so in this way, So one more example. For now, if we want to specify our own transformer, so in previous example we have seen that we have not given any transformer. Now I want to give a GPT model. Okay, so this is GPT model, GPT-2. From transformers import pipeline, for which task I want to use. I want to use for text generation. Which language model LLM we want to use? GPT-2. Okay, this GPT-2 you can explore from this one. So this is product of OpenAI. So this is GPT-2. Here also it is given by which way we have to use this transformer. So you can see in this way: model, OpenAI community, GPT-2. If you want to train your own transformer, if you want to train your own model, own LLM, that can also be done. Okay, so you can see that this, and now we will execute it. So which model we are using? Okay, generate text. For text generation we are using GPT-2 for text generation, and in few lines of code we will be able to work. Okay, we want to generate text depending upon this input. Okay, and very soon it will be generated. So you can see that this particular content is generated. Okay, a single line or a single paragraph we want to expand. So we have given only single line, and that particular single line is expanded to a complete paragraph. So you can see that how much content is generated. Same thing we see in ChatGPT. Same thing you might have seen in case of Gemini or Copilot. Whatever content you have specified. For example, you are writing here, write 200 words about AI in machine AI in health sciences. 250 words abstract on IoT and artificial intelligence. So it will generate that particular content. Okay, how many tokens you want to generate? Okay, so for that we will use this particular text generation pipeline. Okay, model GPT-2. In same way, now if we want to use our own model, if we want to use our own transformer, so by which way we will be able to work? Okay, we want to use a transformer, and we want to go for fine tuning. Now we will discuss about one part that is related to fine tuning. What is meaning and of fine tuning, and by which way we can update a specific transformer? For example, this GPT-2 we have taken. In this particular GPT-2, OpenAI GPT-2 or whatever it is, I want to train my own data. For example, this is my data. Okay, so this is one is a paragraph I have taken. Now this paragraph I want to train in a particular AI model that we relate with fine tuning. We want to update the existing model in a particular AI platform. Then what we do for that, for fine tuning or to work on such scenarios, we use certain platforms, and one of the very classical implementation is using vector databases. So when we have to train our own data, in that case we use vector databases, because in case of transformers, as just now we have discussed that when we work with embeddings, when we work with transformers, very first step is embedding. So by which way that particular embedding is done? So that is done with this particular database, ChromaDB, open source for AI applications. Okay, open source database, search and retrieval database. So if I want to create my own embedding model, if I want to work on my own vectorization. For example, this data I want to train. First of all, to train this data, this particular paragraph should be converted to vector format. By which way it will be converted? Where it will be stored? It will be stored in Chroma or Milvus. So many platforms available under free and open source distribution. So you can see vector database, high performance vector database. If I want to train my own model, if I want to train my own transformer, okay, so you can see that in Python, all of these are compatible with Python. RAG, image search, any of these application, if I want to create RAG application, image search, multimodal search, hybrid search, graph RAG. Along with that, there is one more variant, that is FAISS, Facebook AI similarity search, that we use in artificial intelligence in transformers. If we want to create our own language model, our large language model similar to ChatGPT, okay, we want to create a platform similar to Gemini, Google AI Studio, or Perplexity. In that case, we use these platforms. Okay, ChromaDB, Milvus, and so many others. FAISS, Facebook AI Similarity Search. Okay, you can directly search about it. Okay, FAISS vector. Okay, so you will get different types of documentations, and we will be able to link it with LangChain also. Okay, LangChain, Langflow, and different platforms. So in this way, if I want to train my own document, I want to train my own PDF file. For example, you can see add items to vector store. Okay, this one. So these are classical sentence based. If I want to upload a PDF file, if I want to upload n number of document files, and depending upon those document files we want to go. Okay, so you can see that in this way it will be stored. Okay, vector databases, whatever results, whatever document we are uploading, it will be saved in vector format, and we will be able to work in multiple platforms. We will be able to link with it, OpenAI. Okay, now we will see how to work on these platforms. ChromaDB, how to train our own data in a transformer, how to fine tune it. Okay, so for that I'm showing you one demonstration. For example, this one, uh, I'm taking that specific implementation. So in this way, I have used ChromaDB. This is txt file. So you can see here I'm using FAISS CPU. Okay, pip install transformers, accelerate we use to use GPU, TPU, or whatever it is, sentence transformers, because we are using that particular transformer for sentence generation, for sentence transformation. FAISS, this is same Facebook AI similarity search. Okay, and we will execute it on CPU. We will upload file on Google Colab. Okay, so whatever file is there, for example, this txt file I want to train. I After training this particular file, I want to store in particular database. So you can see that create embeddings. So this is same thing what we have seen in that particular presentation in slide. So first of all, we will create embeddings using sentence transformers. So import FAISS sentence transformer. So first of all, we will take a sentence transformer, this mini lm, and inside this we will put our own data. Okay, so you can see that index flat L2, index.add embeddings. So from where this embedding will come? This particular embedding will come from this document, but whether it is a txt file or PDF file or document file. So we will attach vectors of this particular file in this sentence transformer. Okay, so you can see that all mini lm2. If you want to fine tune DeepSeek, ChatGPT based models or similar models, you will be able to take. Okay, so you can see that this one is on all mini. We are taking it for fine tuning. So this name we have called, and embeddings, whatever embeddings we have taken from this document, I will show after uploading. Okay, once it is uploaded, after that we will load the transformer. Whatever new transformer, whatever updated transformer is we have created, then we will call it with a pipeline. With pipeline, now this pipeline is available with our own data. It is having its previous data, along with that it is having the data which we have trained. Okay, so this data plus this data. Okay, so in same way, for example, n number of documents are there in your laptop, and you want to fine tune a particular model, you want to train a specific large language model with your own data, you can do. Okay, so after joining it, so in a specific format, for example in letter format, you might have seen in chat gpt. For example, I'm asking that, okay, give me one email to head of the department for this task, so it will give me that specific format of output. Okay, output will be given in a specific format. Same thing we can specify here. Okay, in which format we need the output. So that prompt, so this is prompt writing. We are giving the prompt, and after that we are giving that particular query. So I am asking it to summarize main points in letter format. Okay, summarize main points from this in letter format. So when we will upload this particular document, so FAISS, after uploading it, okay, so in this way it will be generated. Okay, okay, or simply if we are giving it in this way, summarize this document. So FAISS we are importing, and once it is done, now depending upon that input, how many chunks are there, that prediction will be given. Okay, after fine tuning. Okay, so you can see that these tensors, these blocks, these vectors are updated with new document. Any number of new documents, new files can be uploaded. So you can see that this one, the question is this, answer is. So from that particular query we have given, so what is the context? So this one is the context, so electricity. So from that particular document we have we have extracted the results. So this one context. Okay, if any other document we want to train, or a single line we want to train, that we also that can also be done. Okay, so for example this one on training. Any document we will be able to take, and in that we can update our own documents. So this one, so after uploading whatever document is there, we will be able to get responses. So in this also what we are doing, we are using ChromaDB. In previous example, we have seen FAISS. Now we are using ChromaDB for vectorization, for storing the values, and after that all mini L6 V2 we will update, and with the same pipeline we will be able to use it. So once it is done, then we can train our own document, train.txt, and we will see the results. Okay, so all of these implementations we are doing on Google Colab. I will share this code to all of you at end, so that you will be able to work on it. So these weights, these values, this particular model will be updated with our new data, and then we will get the output. Okay, so if you want to create a custom chatbot, a custom platform, or updated transformer, that we can do. So it is executing now. So you can see that this one. So main topic. So what is main document in this? So which question I have asked? What is main topic of this document? Main topic of this document is electricity theft. Number of persons committed electricity theft. Okay. So I want to verify whether it is correct or not. So you can see that this is my txt file which I have trained, and you can see that this particular output is not exactly copied from this txt file. Actually, with attention parameter and with decoder, with generator, it is changing the lines also. So you can see that topic of electricity theft is most notorious. So here it is not written anywhere in this particular document. Okay, exactly this line is not written. Number of persons who have committed electricity theft. It is not. It is also not written exactly in this particular paragraph. Okay, so what we have, whatever question we have put, whatever query we have asked in this particular chatbot or this implementation, it is giving the responses by shuffling of responses. Okay, by shuffling of these. So you can see that this one, what is main topic. So in same way, so after changing, so in ChatGPT also you might have seen whatever question we put n number of times, every time different answer is there. Okay, it is not happening that same answer is repeated after 1 hour or 2 hours. It will shuffle. In generation, it will generate the sentence, and after generation of sentence, it will change its language. It will shuffle that particular formation of sentence, okay, formation of keywords, and that particular formation of new sentence will be done in such a way that it will be grammatically correct. So all of these statements are grammatically correct also. These are not grammatically incorrect. So from this particular document which we have trained, we have extracted this particular data. Okay, in this way any number of documents you will be able to upload. For example, in next implementation we want to go for FAISS. In FAISS we want to see what is the output. Okay, in same way. Okay, so for example, some other document we have uploaded, and depending upon that new document, what is the output. Okay, so in same way, for example, so any other document you will be able to take. Now if you want to change it, okay, key points, which are the key points. So summarize the key points in words. So this is key point. So this one is key point, and from that particular document it is taken. Okay.